Let's get started. So, welcome to 99 Problems, but Slow PowerShell ain't one, also known as use Profiler to find your performance issues. Quick note, thank the sponsors. The conference would not be possible without the sponsors. Quick about me, I've been a PowerShell user for a very long time. I love Linux. I usually get in front of this. People always ask. This is bare metal, Arch Linux. I am that lunatic. I also love NeoVim. We're going to be I'm starting to think people come to my sessions just to see all the weirdness on my machine. I don't know, but we will be using some NeoVim, not to do editing. It's just where my markdown is. I love mechanical keyboards. Like I warned people, my problem is probably going to be in copy and pasting just because I'm not used to the keyboard on my framework, but we'll get through it. I have a very neglected blog. I don't think that comes through on the projector. I put like decennially, like basically once every 10 years update. That's kind of what it's become at this point. Everything's in Markdown. We won't be rendering it even in the terminal just because I don't feel like it this year. But I love Markdown, so everything I'm going to do today will be on GitHub. It's not there yet. Well, it is for me. It's just not for you. Everything that we're going to be going through will be in a Git repo. And it's mostly Markdown with some PowerShell files. And I am a solution engineer at SciCode. They were nice enough to sponsor me coming. I have some stickers, so if you want a SciCode sticker, come up and see me after. Or if you just want to nerd out about ASPM or application security. I think I already gave you the disclaimer. Buckle up for a lot of terminals and a lot of Markdown today. And again, from last year's theme on the slides, it doesn't come through, but I put my keyboard specs because I usually get the questions about that. So, was anybody here last year for the Can We Make PowerShell Blazingly Fast session? Okay, a few of you. So this was, how do we get here? Why am I back doing more PowerShell performance? Well, I did this session, Can We Make PowerShell Blazingly Fast? And I'm going to blame Justin. I don't know if he's in here, but I went to a side session right after that for PowerShell profiles. And Justin was not only talking about PowerShell profiles, but he was talking about troubleshooting performance in your PowerShell profile. And he mentioned Profiler, and I was like, oh no, like, I just did a whole session on PowerShell performance, and I did not know that this tool existed. So that's the fun story. I even went as far as doing my own really kind of horrible script to measure 2 different time spans. We won't be using that this year. We'll be using a much better tool by Jakub. So with that, we'll hop into the demo. So again, like I said, I'm not going to use Glow or any fancy tools to render the Markdown. You're just going to have to like it as it is. So what is Profiler? Profiler was created by Jakub. If you're not familiar with him or Profiler, you will be at the end of this session, but he's also, at this point, I think the #1 contributor for Pester. So he developed Profiler for a good chunk of his troubleshooting of just performance issues or optimizing performance for Pester when it runs. So that's where Profiler came from. It does work on all versions of PowerShell. When I say that, I just mean Windows PowerShell 5, I should say 5.1, and 7+. Hopefully nobody's using 6. We don't talk about 6. Most of this is going to be using synthetic examples. I actually waffled on this for a little bit. I was like, should I use like real life scripts that are out in the wild? Should I use some of my stuff? We will look at some of my stuff at the end. But why I wanted to use the synthetic examples is because usually when you're looking at performance in somebody's code that you didn't write, it's just like, it's a little less personal. It's a little harder to follow. So just for simplicity to illustrate what Profiler is going to do, you'll see the examples, they're not like super bad. Well, maybe they are. We'll see. But most of them are synthetic. Also, I'm on PowerShell 7.4.6 for a couple reasons. I was talking about a little bit about that before the session started. But largely, if you didn't know, they changed the PowerShell array, the += style array. So they optimized the performance in 7.5. And that would have really thrown off a lot of what I want to illustrate. So I'm actually still on 7.4. This was kind of in development as a session before that came out. Didn't realize until I read the patch notes. So we might do a live update at the end, time depending, and do a little benchmark between the two. So the two key takeaways, use Profile after this, and use PowerShell 7.5 or later, just so you get the new fanciness. So with that, excuse me, got to install it first. And this is nothing crazy. I don't know if everyone else is using the new like PS resource get. I'm still like lukewarm to it. I'm not used to it. I'm a little old school. I like the old PowerShell get, but just using that, just doing install PS resource. It's on the gallery. It's already installed. You can see I have a couple versions, but 4.3 is the latest, so we're good there. And, yeah, I don't need to copy that. And what I usually like to do when I install a new profile, I like to see what the commands are that are included. There's not many. One of them is even kind of like a toy. I guess I like it. It's useful. I've built similar things, but now I know this exists, so I'll probably use this from now on. But most of what we're going to see today is in trace script. Get call stack, get latest trace. We'll talk about that, invoke script, and we'll see this show script execution. But for the most part, everything today is going to be in the trace script. So what is trace script? Trace script, basically, you feed it a script block, and it's going to profile everything in that script block. So we'll see a lot of this. You're going to get a lot of information back. So when you put something in that script block, not only will it look at that code, but it's very similar to Pester where, it's very similar to the PowerShell debugger where if you keep stepping into, sometimes you'll notice, wow, I'm like stepping into other people's functions and things of that nature now. Profiler is going to do the same thing. So if you're calling a dependency that has a performance issue, Profiler will help you identify that. But for the most part, that's a little bit outside of your control unless you want to open up a PR or something in somebody else's repo. It's very useful for figuring out your own performance issues. So just know trace script block, at its minimum, it's about that easy. Tons of detailed output. If you forget to save it in a variable, you can use the get latest trace. We'll see that. And you could really use this to test anything. I'm going to pick on my own PowerShell profile at the end. I'm going to pick on a module I'm writing for some .file management. I don't know if it's going to work on this machine. We'll see. But yeah, you can use it for anything. Jakub uses it, like I said, a lot for pester optimization. Let's take a very serious example here where we're going to generate some GUIDs. Oop, see, that's what I said. I'm going to struggle most with the clipboard, and it's mostly a keyboard issue on my side. User error. So that ran very quickly. So you can see right off the bat, the script block's very simple. We're defining a range 1 through 10. We're going to for each loop through that, and we're just going to generate some GUIDs and output those. We're not going to see that just because Profiler is not going to show us the output, but very simple, but you get a ton of information. This kind of verbose output in the pink, the magenta, where you're going to see just the trace start, some of the timing around it, like the wall clock time, the actual processing time, how many trace events there were, kind of analogous to a hit count, which you'll see in some of the output. And you have these variables that get defined when you save the trace into a variable, like top 50 self duration, top 50 memory. We're mostly going to be looking at duration and self duration today, but if you had, say, some code and you were worried about memory optimization, those variables have that information. So you can see what parts of your code might be using more memory than other parts. If you're maybe like writing something for a Raspberry Pi, I don't know. I also will say, so this isn't my usual laptop. I have a 3:2 aspect ratio, so I'm going to do a lot of select object and pipe that to format table just to fit it because my screen is taller than wider, so bear with it. But there's a lot of information that comes back with these. Also, you'll see at the bottom, it says, oops, looks like you didn't assign a variable, and if you do that, you can run get latest trace. And if you want, you can save that in a variable, but that's a way that you can, if you forget to save it into a variable, it stores it for the last trace. So if I run a new trace, it'll get overwritten, but just know if you forget, you can get back to it. And we'll do that right now. And here's where I just stored get latest trace into a variable $T. That's my favorite lazy variable I use for everything. It actually makes sense here. You could say T for trace, but usually when I can't think of something I need to store, I just use $T. And I'm dotting into that top 50 duration, and then I'm selecting the percent duration, self-percent, hit count line text. But again, this is a very simple example, but we can see top 50 duration, and I'm going to talk about this in a minute. We can see that the percent for the duration doesn't always add up to 100. It's going to be over 100. But the self duration and the self percent, that's really what took the most time or least time to run, depending on how you're looking at it, within the script block. So in this case, the new GUID, and then dotting the GUID out of that took 80.62% of the time, where the other part of the code took the other 19.3%. So if I wanted to optimize this might be a place where I'm like, was there a more efficient way to generate a GUID that I can shave off some time? Oh, and this one's cool. So this is more of a toy. This is the show script execution. And what I love about this is it just kind of walks through each step, and it's a cool way to visualize what's happening. There's a lot of material that Jakub has done on this, and I think he said this is like more or less kind of a, not like a, I don't know if he said like a novelty feature. I just love it just to see what the output is. That first new GUID's a little slow. You can see that. We'll talk about preheat in a little bit, but. Oh, and the X1000, that parameter just made it run slower. If I didn't pass anything, it would have just gone whoop. So there's like a -X100, -X1000, -X10 that just helps you control how fast it outputs for the most part. So let's get a little deeper with trace script. How many people love GUIDs? And you're like, I need to generate so many. But I don't know how many is too many. Maybe you want 20 GUIDs, maybe 50, but you feel like 50 might be too greedy. So we have a very real life script. Ooh, not that directory yet. Where we're not going to be too greedy with our GUID generation. We're just going to generate 25. That seems reasonable. So again, defining a range, that's just our count. I could do a for loop. I love for each. We're going to do a PowerShell array. This is the old style still, because I'm on 7.4, so this isn't the new fancy plus equals. And then we're just going to iterate through those 25. We're going to generate a GUID, and we're going to plop that in the list. So let's trace it. You know what? Just for the interest of time, let's copy both those. So I'm going to run the trace. And we get that same info as last time. That's great. And then I want to say, show me the top 50 self-duration. And again, self-duration is really introspective of like the things inside my code that I care about, where duration is kind of from the entry point down. I'll get into a little bit more detail, but I just know last time I think I did duration. This time I'm doing self-duration. And we can see here, and this is interesting because this kind of flip-flops all the time I've been testing it, that sometimes I've seen, as we can see here, line 7, the plus equals, sometimes that's on the top for the slowest performance. Sometimes it's the generation of the GUID in that string formatting where we're just plugging in the GUID and the numbers. So, but what's nice here is I can look at this, and again, just like before, I can say, well, 2 issues, because I can see, on line 6, I have my list item where it's generating the GUID, it's doing the string formatting. Maybe I can save a little time there. Maybe there's a faster way to format strings. I don't know. We're not going to go that deep today. This is more about finding the issues and a couple things you can do to troubleshoot the optimization process. If you want to see the detail of like for each versus for each object, that's the session I did last year. And then we can also see, as expected, the list plus equals list item. That's 23.8% of the time run. So those are where I'd probably want to start making my optimizations. So the duration versus self-duration. I've talked about this a little bit so far, and I have the AKA just because it's how I kind of wrap my mind around it. Duration is the time from when you entered the function or a script and then left it, which is why you'll always have numbers that don't quite equal 100%, where self-duration is the percent of each individual bit that you've seen run. So if we go back, the self-duration here, that's why we're seeing each one of the lines run. And one thing I just want to call out, when you just stuff a script block, like I have been doing, when you stuff the script in a script block, the file, the entry point is just going to be a GUID. That's just what, when you run PowerShell, the interpreter just gives it a GUID. That GUID has nothing to do with generating GUIDs. That's just the entry point. Because you can see here, line 1, that's the // on the script. So that's what those GUIDs are. It's just something that got generated. But yeah, just remember, duration's top down from like the outside looking in. Self-duration is a little bit more useful for what you're looking to do. at the end of the day, it kind of depends on like, where's my performance issues looking from the top down, from like where I'm entering and exiting, or where are the performance issues for each individual line. So here we have a very real life example. I'm gonna have this script block, and we're gonna have a few functions. We're gonna do function invoke A, which will return A. We have function invoke B, which returns the letter B. Ignore the start sleep. We're gonna have function invoke C, which will return C. And then we have invoke letters, which calls all three of those, and then we call that. So, and again, I could have used real code, but like conceptually, this is like way simpler to see. Like you can see here where the obvious bottleneck's gonna be. And then it's just the lack of personality, I think, makes it a little bit easier to illustrate. So again, we have the script block now. We have that, it's good to go. So let's do a trace on it. And this is probably gonna be what you would expect. Oop, there's my copy and paste. I'll talk a little bit about progress. You might notice the red and the yellow at the bottom. We'll get there. But we have our trace. This time we stored it in trace. You know what, I'm gonna just go by duration with the formatted, just so it's not scrolling off and truncating. So here, the duration again, the percent's not gonna equal up, but if you look at the percent here for duration, you'll notice the first three there. We have like 99.98, 99.86, because we're seeing that's from basically from that entry point, what's gonna be the slowest pieces, but the self percent and the self duration, that's showing us where the worst performance is in the pieces that we've, that we care about, that we can optimize from like within our code, which is why you see on line 3, that invoke B, we see even the start sleep 1 second line, 99.82% of the processing time. So, which obviously we knew that was gonna happen just because we're putting a sleep in. And likewise, this is just a different way to kind of view the same information. But as expected, you can see that from the self duration perspective, 99.82 was that invoke B calling the start sleep. So very on the nose example there. But that's when you start diving into this with your real code, you'll be able to see like at a line by line level, okay, well, these parts of my code are taking X amount of percent of the time. That's where I want to start doing my optimizations. Yeah, we'll just move on. So let's get a little bit more crazy. This one is admittedly hard for me to illustrate. I don't know if you guys have any code that has like a slow startup time, or you need to, stuff gets loaded into memory. It's like always slow on the first run and subsequent runs are faster. There's a preheat parameter on trace script which allows you to execute so many pre-runs before the actual trace you want to look at. And again, it's kind of that scenario where you know you're going to have to load stuff into memory, but after it's nice and warm, you're good to go, and that's where you want to get the performance numbers. So preheat lets you avoid the performance issues of maybe those first-time runs. I like to think of it, I don't know if anybody plays video games, you're playing a game, it loads up, you're doing whatever, you die in the game, and then when you respawn, the load's a lot faster because a lot of the bits for the game are already in memory, so think of preheat like that. I'm going to be using the Alice in Wonderland book. I don't know if you guys know, there's the Gutenberg library. It's a library of free books with free license to use for whatever, if you want to read them. We're just going to be parsing Alice in Wonderland and using that as some of our example for performance here. And I will be downloading it multiple times later, so don't tell the Wi-Fi police. Just to show this really is, well, let me make sure I go, there we go. Now we're gonna be in 2. This is Alice in Wonderland. I will fully admit I've never read it. I think I watched a movie one time, but this is the whole big book. So let's count how many times, and there we go. Let's count how many times the name Alice is in there, just using select string. 400, which probably is a little. Yeah, that's just to get content, like piping to select string. That's just raw PowerShell at that point. So it shows up 400 times total, inclusive of like the little intro license about the Gutenberg library. So let's do this. Let's do the cold. So what I'm going to do here is I'm just not passing the preheat parameter. And that took us about 0.40 like seconds, or milliseconds. Yeah, 40 milliseconds. And let's do it with the preheat. So, sorry for the resolution there. So at the end of here, I'm just going to do a preheat 5. So it's the same line as we saw 6 lines up. This time I'm just doing the preheat 5. And the output changes a little bit. So you can see at the very top there, we have warm up 1, 2, 3, 4. That's where it's running those 5 times before it actually runs the one that we're going to store in the trace. And this one's usually pretty close. I just couldn't think of a good example, honestly, of something that was like super memory intensive, but total duration, there we go. Typing hard. With the preheat, it was actually about half the time, which is usually a little bit better than when I was doing this in like test examples. So with the preheat, which is the warm, the one we stored, the trace we stored in the warm variable up there, 23 milliseconds first without the preheat, 40. Again, you probably could think of a more real-to-life example, but just know that preheat is there for those cases where your initial run might take some more time and you just want to warm it up before actually doing the trace. Flags is another really cool thing Profiler can do because there's more or less the way I think about it. You guys familiar with feature flags in software to enable certain parts of code to run or not run? That's what flags in Profiler do. It's a great way to have 2 different blocks of code and have them live side by side. Specify the flag in Profiler so that you can run it. You can run it before and after. That part confuses me a little bit. I will fully admit that. We'll talk a little bit about before and after, but what it does, and Jakub recommends usually storing these in a Boolean. I agree. I haven't thought of any scenario why you'd want to complicate it more than that. And you wrap it in an if block, and we'll look at this. And you pass the flags, and it's basically just stored as a global variable. So whatever you name the variable here, in this case, in my example, we're going to have optimized test equals true. And if Profiler sees that flag, it'll run a various block of code accordingly. So let's look at our script. So here we're going back to the GUIDs. We'll return to Alice in Wonderland. We'll go further down the rabbit hole. But we have 2 versions of the same code here. We're going to iterate 1 through 20,000, and we're going to use the pre-PowerShell 7.5 plus equals to add that to an array, versus defining a system collections generic list, in this case just of strings. Actually, I probably could have done it of type GUID. Maybe that's a performance optimization, I don't know. So we're being a little sloppy here. But the real focus of this is line 22 and line 26 and 11, where we're just basically adding to those different types of collections or arrays. So with that, let's run the optimized one. And let's see, do I have? Well, we'll remove the flag. We'll go in the order that I have in my markdown just so I don't get all out of order here. And I'm going to store these in a variable. One's called trace opt for optimized. One's called trace pre-opt for pre-optimized. And as you saw, the optimized one, the first time I ran it, ran pretty fast. The second one, as we expected, ran a lot slower. And if I look into the details of that, if I just look at the total durations here, we have the difference of about 1.2 seconds versus 6.2 seconds. So again, upgrade to PowerShell 7.5 for the better plus equals array style. But if you're not, you can actually see why that is so imperformant, if that's a word, lacks performance compared to its other like .NET, system collections list or array list counterparts. And there we go. I think next year I'm just going to bring my actual mechanical keyboard. I just don't know if there's enough room up here. And if we look at the difference between these two runs, you can see the list pieces of the less performant, the pre-optimized run, the plus equals here was eating 72.69% of the run, where the slower part of the optimized run was still in the string formatting, the generation of the GUID like we saw earlier, but the actual list addition and generation wasn't as bad. So again, update to PowerShell 7.5, or just don't use plus equals. I probably will still use generic lists. It's just my preference, but everyone's a little different. And now I wanted to talk a little bit about progress. So let's rerun this one. So the pre-optimization, this is going to take a minute because it's pre-optimized, so we're going to do the plus equals. The progress at the bottom, it keeps adding, and sometimes you'll see the A and sometimes you'll see the B. And the A stands for after and the before stands for before. There's a before and an after when profiler runs. So when I do pass the flag for optimized test for the pre-optimization, by specifying before, it's running that pre-optimized version of the code to use basically the inverse of the variable. These do get a little chewy for me to follow. But the main thing is that progress is always going to compare the last run. You might notice that even between these random different examples, it just keeps adding. So if you are within one PowerShell session, you could run profiler against your user profile, and then you could run profiler against the module you're working on. You'll still see the progress, even though those aren't really apples to apples. So it's more apples to apples when you're comparing the same thing over and over again. But just remember, the A is after, B is before. And I think invoke script, we're going to see this more prominently here. So invoke script gives you a way to leverage the flags and orchestrate a repeat. So you can run the optimized version and the non-optimized version X number of times and see the differences between those. This is really cool. It more or less just sets the flags to true. Or it sets the flags to false. I apologize, I'll go back and look, but you'll see here it's running, so we see run 1 before, we see the time it took, and it's running the after, we see the time it took. Run 2, we're going to be on run 3. It's going to give us a nice little before and after output. And I like this a little bit better than the progress you just get on traces output, because you'll see right now, there we go. For each run, you have the before and the after. And clearly, the pre-optimization is much slower, and then we can see the post-optimization being significantly faster. So this is the much better way to do leverage the before and after, at least for me. Sorry, this is my preference. Your mileage may vary, but I like this for kind of doing apples to apples, X number of runs. Performance. So let's actually optimize now. So we found our issues. We're going to go back to Alice in Wonderland here. We know how to use trace script. We've kind of hit all the fun points of it. So we need to go to the book. We got to count all the words, and we need to identify the top 10 most used words, and then we need to group those top 10 most used words. I do this all the time at work. I'm asked to group free library books by top 10 most. I'm joking, but again, very simple example just to illustrate how you would go through the optimization process. So let's do this. So you already know we have dallas.txt, that's the book. And we have our script. So just to add some more performance-related pieces to this, we're going to download the book. Just outfile it to Alice. It's already there. It's still going to run. We're going to get all the words. We're going to do this and that. And more or less, we're just going to count the words and group them. So this is pre-optimized. You can see on line 19, where he's going to do the old style array with the plus equals to add to the all words list, which is defined on line 5. So again, we know this should be slow unless you're on new PowerShell. And what does it look like to run? Let's run it. Here's the download. This is usually fairly fast. There's a lot of words. I actually had a hard time finding a book that wasn't too fast and wasn't too slow, but then I did most of this on my desktop, so now it's like probably a little slower than I wanted because it's my laptop. But here's the output, real cool. And there's like this whole like Pareto principle Zipfian thing, so like obviously, if you ever like this whole thing about languages, not surprisingly, it's the and to of it. Like these are some of the most common words that are used in English, so if you're a language nerd, you'd probably be expecting to find the list we just got back. But the script works. Cool. So let's trace it. And actually, you know what? I'm going to do that just so you can see why I keep doing the select object and format table. So we'll run the trace again. It's going to take a little bit because we're going to have to re-execute the script to get the trace on it. If we want it to be slower, I could preheat, so we run through it X number of times before actually getting the output. But there we go, cool, we have it. And if you wanted to see like what these look like, it just like we only get a first few fields and it just like scrolls off the screen, which is why to look at the self duration, what parts of our Alice in Wonderland parser for words was slow, this is more what I want, because I want to see the line, the text, the hit count. And again, as expected, 82.08% of the time, line 19, the plus equals is the most problematic part. So if we want to optimize this, we should switch to a generic list or an array list. So now we can optimize it. So in this case, I've just done a fix. So by doing a whole other file. And this is very similar to before where the only difference is, oh, maybe I didn't. Well, let's run this. Oh, yeah, sorry. This file contains both copies. So I'm going to use the flags again. Should have read my own notes. We're going to have the flag called fixAlice. So if we specify the fixAlice flag, we'll be running the optimized version. Otherwise, we'll be running the old slow version. And I will do this. And I see that I do a trace multi. I don't know if we want to do that just because this runs a little slow. So this is the optimized run. Remember how slow that was before? I just sat up here like really awkwardly, silently while we were waiting for it to parse and return the words. The fixed version ran much faster, and now you can see we have kind of an equal split. Invoke web request, not surprisingly, is probably one of the least performant parts just because on conference Wi-Fi we have to go out, download Alice, so and then the for each iteration for each word in words was slightly ahead by like 0.7, 0.6 something. And I might kick this off, but, well, let's see. Let's run it. Oh, we're just going to do both. We'll do it. Did it do what I wanted? I think so. Either way, we already talked about flags. Just know that it's a good way to compare the two runs, and the flags let you run the optimized part side by side with the non-optimized part. All right, this gets a little niche. This is kind of more of a fun feature. That's a fire chart or fire graph. It's called speed scope. Flame chart. Speed scope is a viewer for flame charts, which just is a way for performance-related things, whether it's like performance on servers, code, to visualize the run of it. So you can output in this speed scope format. Whoops. So see, I'm passing a parameter called export path Alice, and that's going to output the speed scope. I think it's a JSON file, we'll check in a minute, that I can use. You can run speed scope locally. Now, again, I'm hoping I installed it on my laptop, we'll see. But if I just do an ls here in my local directory, I have alice.speedscope.json. So the path's just going to give it the name you want. .speedscope.json is the extension. With that, do I have speed scope installed? I do. let's see. This is going to be brutal to probably view. Let me see if I can zoom in. But there's a few different ways you can view this. And this one's chewy because, especially if I scroll over, once we start like looping through all the words, we can see like every run of basically parsing the words, which there's many words in Alice in Wonderland. These flame charts vary. Your mileage may vary. I just wanted to show you that if you're into flame charts, you can generate this. This is time order. You can say what's left heavy, which again, sorry for the resolution here, but you could see the chunkiest parts. Yeah, and then there's a sandwich view. I like living in the terminal, so I like to use the information that Profiler gives me and just look at the self duration. But if you are into flame charts, you can extract from Profiler and then use speed scope. I do have speed scope installed locally, but if you go to the website, I think it's like speedscope.app. You can upload it there, but obviously if there's stuff in your code you don't want to upload to a public place, be very careful about that. And let's have a little fun now in some of our time remaining. So, I just called this miscellaneous. I wasn't feeling creative. So here's some more practical examples. I'm going to pick on myself here. I have a and Andrew asked me for a link to my profile. So my profile is in a GitHub gist, and it is a hodgepodge of nonsense from who knows when. I've been tweaking this thing for years. I keep it in a gist because I want to copy with this profile launch code, and regardless if I'm on Linux or Mac or Windows, I want my profile to always pull from the GitHub gist so I have the same profile in every machine. And I do a lot of like probably really poorly optimized code to install OMyPosh, and then because of the cross-platform stuff, like I had to add all the Mac stuff recently. It's a mess, but just know this is my profile. You can make fun of it. I do have OMyPosh theme. I made my own one because I'm I like to turn a lot of knobs. But this is the profile itself, and we're going to run Profiler against it. And this was not super surprising to me when I first did this. But this is a very common use for Profiler. Oops. And we got to copy the right path. There we go. Whoops. So you can see here what I'm doing is I'm calling a new PowerShell session without a profile. I'm telling PowerShell not to exit, and then the command I'm feeding it is a trace script to execute my profile and load it. This way I'm not loading my profile and then rerunning my profile. Like, this is as fresh as it gets. And on conference Wi-Fi here, what it took us, let me look at the trace, about 3 seconds? Not great actually. There's been times in the past I had a PowerShell version of my profile that took about 30 seconds to load. I'm not proud of that. I didn't know about Profiler. I don't even know if it exists back then, but still 3 seconds isn't great. I haven't optimized this. We're not gonna, but not in this session. But let's just take a look at what the slowest pieces are. And we might need to do a little, we're gonna need to, 1 second. Let's do it this way. I forgot I had that line. Again, that's why I'm doing the piping to the select object. All right. Now let's look at that. That's a little bit better. Not surprisingly, and you can see all the files here, and this is a more practical use than the ones we were looking at for Profiler. And it's like, okay, well, jeepers, I have a lot of invoke web requests happening, and the invoke expression there. And if you want to learn about invoke expression, come to my session in this room after the break. We'll be talking about PowerShell security and invoke expression very specifically. But I can see those things that are making calls out to resources on the web are the slowest pieces, and that's going to be a hard thing to optimize, just because even here I'm at the mercy of the Wi-Fi. Maybe I could optimize it by checking my network adapter, and if I'm on Wi-Fi, not loading it. But not surprisingly, I can see the two top ones are actually invoke web requests. That fourth one down is the invoke expression. I think that's doing something for OMIPosh. And the only one that's not a web-related call is the third one, where I'm getting a get file hash. And that's the case where I'm like, okay, that one's a little bit more inside of my control. That might be a place where I want to start optimizing. But what's interesting, I use terminal icons. So if you use like get child item, if you want to have the fancy icons, that's where those are coming from. And I can actually see there's a lot of that module that's getting loaded. I have some PowerShell get. Because I'm doing some module checks that I've defined in my profile, I can see posh get loading. Quite a few different things here. The nice thing I can see within the file of my profile, the Microsoft.PowerShell_profile PS1, those are things I can control outside of that. Maybe I don't load terminal icons, or maybe I don't implicitly import it when I load my profile. That might save some time. But we can see that the self percent is around 2% for those, so they do add up, but largely the web calls are the slow part. And I will say, if I do a connectivity check. If I can't connect, my profile just outputs a warning saying you're not on a network, so I'm not going to try to load anything. It just dumps me into the plain Jane PS with the directory. So I do at least a little bit of optimization there. And I don't think I'm going to run the dot files. I'm going to try to do a live update to PowerShell 7.5, but I will take any questions while I do. So any questions so far? Or any questions in general? Yes. Yeah, good question. The question was, can you step into, like, on a given line, if you're doing multiple definitions, like within the line, can you step into a smaller piece of that, correct? I don't know. I don't think so. That might be, I just want to make sure I'm not updating more than I want. But that was a good question. I don't actually know the answer. I don't think so, though. I'd have to go back and look. I saw another hand. Yeah, the question was, if you're using the plus equals pre-PowerShell 7.5, why is that slower than instantiating like a system collections generic list of a type or a system collections array list? So under the hood, before PowerShell 5, and I'm probably going to butcher this, some of the PowerShell folks will probably do a lot more justice, it would create the array, and then every time you appended something or tried to add to it with the plus equals, it would delete the entire old one, the old copy, and it would create an entire new copy, which is really performantly bad because you're basically destroying something and recreating it rather than the other ways of doing it where it's just appending to an existing list without having to do the whole deletion and recreation. So at a very high level, that's what it's doing. And I think I actually just updated everything but PowerShell. So we might not have the time to test it, but just know, update to PowerShell 7.5 because the plus equals, I don't know how it stacks up in 7.5 versus the alternatives from a performance standpoint. I didn't test that thoroughly, but it was a major patch note in the release. So it's not as bad as what you saw today. Everything you saw today was a bad example of that. Any other questions? It's on par. Okay. So somebody said it's on par, which is good. Nice. Cool. Well, thank you for coming. That's okay. Cool. Awesome. Yeah, we're even still, things are a little slow here, so I'm going to cancel it. But update to 7.5, and that's using Profiler. Come find me if you have any other questions. But that's all I got.